Hi, welcome to Big Data Analytics course. In this lecture, we will discuss HDFS command line interface followed by Hadoop file systems. The command line interface here basic file system operations are going to be covered. Then Hadoop file systems interfaces are going to be discussed later. First coming to HDFS, the command line interface. Here, basic file system operations. There are many other interfaces to HDFS, but the command line is one of the simplest and to many developers the most familiar. We are going to run HDFS on one machine. So first to follow the instructions for setting up Hadoop in pseudo distributed mode. Later to run HDFS on a cluster of machines to give us scalability and fault tolerance. There are two properties that we set in the pseudo distributed configuration. The first is fs.defaultfs set to HDFS under localhost URL, which is used to set a default file system for Hadoop. File systems are specified by a URI, Uniform Resource Identifier. And here we have used an HDFS URI to configure Hadoop to use HDFS by default. The HDFS daemons will use this property to determine the host and port of the HDFS name node. We will be running it on localhost. On the default, HDFS port is 8020. And HDFS clients will use this property to work out where the name node is running so they can connect to it. We set the second property, dfs.replication, to 1 so that HDFS doesn't replicate file system blocks by the default factor of 3. When running with a single data node, HDFS can't replicate blocks to 3 data nodes, which is the default one. So it would perpetually warn about blocks being under-replicated. This setting solves that problem. Then what are the basic file system operations? We call it as HDFS commands. The file system is ready to be used and we can do all of the usual file system operations such as reading files, creating directories, moving files, deleting data, and listing directories. These are all the major operations. We can type Hadoop space fs space -help to get detailed help on every command. Let us see some of the basic file system operations, that is HDFS commands. In upcoming video, we will see hands-on demonstration of all these file system operations. The first one, to get the list of directories and files at the root of HDFS, we'll use the following command, that is ls. The syntax is Hadoop space fs space -ls space /, which gives the list of directories and files at the root of the HDFS. Then to get the list of complete directories and files of HDFS, same as previous command, we will use -r space / Hadoop space fs space -ls space -r space / To create a directory in HDFS, for example, Big Data Analytics, BDA directory we want to create in HDFS environment, the command is using mkdir make directory. The syntax for this is Hadoop space fs space -mkdir space / name of the directory. Here we assume BDA. Then to copy a file from local file system to HDFS, for that we will use put command. The syntax is Hadoop space fs space hyphen put. You have to give the source path space slash root slash bda slash test.txt. Let us assume. Then space destination. In HDFS directory you can give slash bda. We created already. In that the same file name you want to move, that is test.txt. The same name you want, you can give. The next operation is to copy a file from HDFS to local file system, or now reverse. For that we will use get command. The syntax is Hadoop space fs space hyphen get. You can give the HDFS path first, that is destination path. So slash bda in that test.txt space the local file system path you can give, that is a root under that bda under bda test sample.txt. Then to copy a file from local file system to HDFS via, in place of put command, we will use copy from local command. Everything same. In place of put, replace it by copy from local. In copy from local, from F capital, local, L capital. Copy from local is a single word. There is no space. So the syntax is Hadoop space fs space hyphen copy from local space. First, you can give the local system path, that is root, under that bda under the file name test.txt to HDFS directory bda. In that the file name test sample.txt. You want to move the file with the file name, whatever we will give, that file is renamed with this. Then to copy a file from Hadoop file system to local, for that earlier we used get command. In place of get, the alternative one is copy to local. Here to T capital, local, L capital. Again, copy to local is a single one. The syntax is Hadoop space fs space hyphen copy to local. Then you can give the HDFS path first. BDA in BDA directory, the file name is test.txt. Then the local system path is root under root directory. The subdirectory is BDA. In that, the file name test sample1.txt, whatever the name you want, can give. Then to display the contents of HDFS files on console. For that, we will use cat command. The syntax is Hadoop space fs space hyphen cat. You can give the HDFS path name BDA. In BDA directory, the file name is test.txt. Then within HDFS, you want to copy file or directory from one directory to another directory on HDFS. For that, we will use cp command. So the syntax is Hadoop space fs space hyphen cp. So the current directory BDA in the test.txt. You want to copy from BDA to another new directory BDA1. Here you can observe whenever you can use copy command in the original source directory, the original file remains same. Only one copy will be copied to another directory. We have another alternative one. In place of copy, we have move. For that, the command is mv. Whenever you can use move in place of cp, permanently the file test.txt moved from BDA to BDA1. Now in BDA, no file exists with test.txt. Permanently it moves. Whereas copy means by keeping original file, one backup will be taken and copied to another new directory. We have another command to remove a directory along with files from HDFS. For that we will use rm. So the syntax is Hadoop space fs space hyphen rm hyphen r space slash, give which directory you want to remove. For example, BDA1. Suppose you don't want to remove entire directory, you want to remove only a specific file. Then here you can give under this BDA1 directory slash give the file name. For example, test.txt. Then only that specific file is removed. Here hyphen r stands for so recursively it verifies from the root directory. Yeah, these are all some of the basic file system operations. In upcoming video, we will demonstrate all these commands with hands-on demo. Then coming to Hadoop file system. So here, let us see about the role of interfaces in Hadoop file systems. Hadoop has an abstract notion of file systems, of which HDFS is just one implementation. The Java abstract class org.apache.hadoop.fs.file system, which represents the client interface to a file system in Hadoop. And there are several concrete implementations. The main ones that ship with Hadoop are shown below. The following table shows various file systems and their uniform resource identifier scheme and Java implementation path, the description. First file system local. The URI is file. Its Java implementation under prefixed with org.apache.hadoop property. Continuation with hadoop.fs.local file system. The purpose of this one is a file system for a locally connected disk with client-side checksums. Use raw local file system for a local file system with no checksums. The second file system, HDFS, what we are studying now. HDFS is the URI scheme. Its property under org.apache.hadoop.hdfs.distributed file system. Its purpose is Hadoop's distributed file system is designed to work efficiently in conjunction with MapReduce. Then Web HDFS is the next file system. Its URI scheme is Web HDFS. Its property org.apache.hadoop.hdfs.web.web.hdfs file system. So its purpose is a file system providing authenticated read and write access to HDFS over HTTP protocol. The next file system is Secure Web HDFS. Its URI scheme is SWeb HDFS. Its property org.apache.hadoop.hdfs.web.sweb.hdfs file system. Its purpose is the HTTP's version of Web HDFS. Then the next file system is Hadoop Archive. Its URI scheme is HR. Its Java implementation path is org.apache.hadoop.fs.arc file system. Its purpose is a file system laid on another file system for archiving files. Hadoop archives are used for packing lots of files in HDFS into a single archive file to reduce the name node's memory usage. Use the Hadoop archive command to create ARC files. The next file system is Vue. The URI scheme is VueFS. Its Java implementation path is org.apache.hadoop.vuefs.vue file system. Its purpose is it is a client-side mount table for other Hadoop file system, commonly used to create mount points for federated name nodes. The next file system is FTP, File Transfer Protocol. Its URI scheme is FTP. Its Java implementation path is org.apache.hadoop.fs.ftp.ftp file system. A file system backed by a FTP server. Then another one is S3. Its URI scheme is S3A. So here S3 is nothing but Amazon Simple Storage Service, abbreviated with the acronym S3. It is actually replaced with older S3N. That means that is native. Its Java implementation path is org.apache.hadoop.fs.s3a.s3a file system. The next file system is Azure. Its URI scheme is WASB. Its Java implementation path is org.apache.hadoop.fs.azure.native Azure file system. It is a file system backend by Microsoft Azure. The next file system is Swift. Its URI scheme is lowercase letters Swift. All URI schemes are lowercase letters only. Its Java implementation path is org.apache.hadoop.fs.swift.snative. Swift native file system. So it is a file system backend by OpenStack Swift. Those are all some of the file systems with their URI scheme and Java implementation path. Hadoop provides many interfaces to its file system, and it generally uses the URI scheme, what we have shown in the above table, to pick the correct file system instance to communicate with. For example, the file system shell operates with all Hadoop file systems. So if you want to list the files in the root directory of the local file system, we have to type percentage Hadoop space fs space hyphen ls space file colon. You can give the path of the local file system which displays all the files in the root directory. Although it is possible, sometimes very convenient, to run MapReduce programs that access any of these file systems when we are processing large volumes of data. We should choose a distributed file system that has the data locality optimization, notably Hadoop Distributed File System, HDFS. Then with all these URI schemes, now how interfaces? Hadoop is written in Java. So most Hadoop file system interactions are mediated through the Java application programming interface. The file system cell, for example, is a Java application that uses the Java file system class to provide file system operations. The other file system interfaces are discussed briefly here. These interfaces are most commonly used with HDFS since the other file systems in Hadoop typically have existing tools to access the underlying file system. That is FTP clients for FTP, S3 tools for S3, etc. But many of them will work with any Hadoop file system. The next interface is HTTP. By exposing its file system interface as a Java API, Hadoop makes it difficult for non-Java applications to access HDFS. Then by using HTTP REST API, here REST stands for Representational State Transfer, exposed by the Web HDFS protocol, makes it easier for other languages to interact with HDFS. Here, one of the important thing to remember, so that HTTP interface is slower than the native Java client. So should be avoided for very large data transfers wherever possible. There are two ways of accessing HDFS over HTTP. Directly, where the HDFS daemons serve HTTP request to clients and via a proxy or proxies which access HDFS on the client's behalf using the usual distributed file system API. The two ways are shown in the below picture. Both uses Web HDFS protocol. Here you can see the first one is direct access, second one HDFS proxies. In direct access, we are having clients and name node, data nodes. Then the communication among clients to name node, clients to data node directly. Whereas through HDFS proxies, so between client name node and data node, we have the HDFS proxies directly. We can't access through proxies only. We have to access. Here you can see client to HDFS proxy, then HDFS proxy to either name node or data node, like that communication. So in this, the solid line arrow represents HTTP request. Then the dotted arrow represents RPC request, that is remote procedure call request. Then normal dashed arrows represents block request. Here you can see the differences. Three types of communications are there. So finally, this figure accessing HDFS over HTTP directly and via a bank of HDFS proxies. In the first case, that is direct access, the embedded web servers in the name node and data nodes act as web HDFS endpoints. Here, web HDFS is enabled by default since dfs.webhdfs.enabled is set to true. File metadata operations are handled by the name node, while file read and write operations are sent first to the name node, which sends an HTTP redirect to the client indicating the data node to stream file data from or to. Whereas in the second case, that is through HDFS proxies. So the second way of accessing HDFS over HTTP relies on one or more standalone proxy servers. Here the proxies are stateless, so they can run behind a standard load balancer. All traffic to the cluster passes through the proxy. So the client never accesses the name node or data node directly. This allows for stricter firewall and bandwidth limiting policies to be put in the place. It's common to use a proxy for transfer between Hadoop clusters located in different data centers or when accessing a Hadoop cluster running in the cloud from an external network. This is the second case. So the HTTPFS proxy exposes the same HTTP and HTTPS interfaces as Web HDFS. So clients can access both using Web HDFS or SWEB, that is S Web HDFS URIs. The HTTPFS proxy is started independently of the name node and data node daemons using the httpfs.sh script and by default listens on a different port number, that is 14,000. Then coming to another interface, C programming language. Here Hadoop provides a C library called libhdfs that mirrors the Java file system interface. It was written as a C library for accessing HDFS, but despite its name, it can be used to access any Hadoop file system. It also works using Java native interface, that is JNI, to call a Java file system client. There is also a library web HDFS, that is libwebhdfs library that uses the web HDFS interface. The C API is very similar to Java 1, but it typically lacks the Java 1. So some newer features may not be supported. We can find the header file hdfs.h in the include directory of the Apache Hadoop binary tarball distribution. The Apache Hadoop binary tarball comes with pre-built library HDFS, lib HDFS binaries for 64-bit Linux. But for other platforms, we will need to build them ourselves by following the building.txt instructions at the top level of the source tree. Then coming to the next interface, NFS, Network File System. It is possible to mount HDFS on a local client's file system using Hadoop's NFS v3 gateway. We can then use Unix utilities such as ls and cat to interact with the file system, upload files, and in general use, we'll use POSIX libraries. Here, POSIX is the Portable Operating System Interface to access the file system from any programming language. By appending to a file works, but random modifications of a file do not. since HDFS can only write to the end of a file. Then another interface is Fuse, which stands for File System in User Space, which allows file systems that are implemented in user space to be integrated as Unix file system. Hadoop's Fuse DFS contribution module, DFS distributed file system, allows HDFS or any Hadoop file system to be mounted as a standard local file system. This Fuse DFS is again implemented in C using lib HDFS as the interface to HDFS. At the time of writing, the Hadoop NFS gateway is the more robust solution to mounting HDFS, so should be preferred over Fuse distributed file system. Okay, these are some of the HDFS interfaces. Okay, in upcoming lectures, we will see other interesting topics. Till then, stay tuned for latest updates.